Exercise 598. This is an optimizing exercise here. We have an area here which we are gonna divide into 4 equally large parts, and we have 56 meters of fence. Okay, so how should we do this? We want to maximize the area, the total area here. And the thing is that we know that, of course, the area here will be x times y, okay? And we want to try and find this area function here. We see that x is fine, but we can't have y here. You have to substitute y in some way. But what we know here is that this plus this plus this plus this plus this plus this plus this is equals to 56. So x plus x plus x plus x plus x plus y is equals to 56. So this is then 5x plus 2y is equals to 56, right? So 5 of these x's, 1, 2, 3, 4, 5 plus 2 y's is equals to 56. And the point is that I want to get rid of y, so I have to find an expression for y, isolate y in this formula here. So I just move 5x over, so I get 56 minus 5x, and then I divide by 2 in each term, and then I get y is equals to 28 minus 5 over 2 times x. So this will be y, and then I can find the area expressed with x, because x times y, but y is exactly the same as this. So instead of multiplying with y, I can multiply with 28 minus 5 over 2x. And if I just multiply then, I get 28x, and then plus times minus is minus 5 over 2x squared. And this is the area as a function of x, like this. Okay, so then we have done exercise A. So start with the formula of what we're finding here, a rectangle, and do a lot of tricks here and you will get the answer. And then exercise B, it says what must the length and width be, what must x and y be if you want the area to be as large as possible. So I want to maximize this area, which means I have to find the maximum point of this function. This, of course, can just draw the graph on GeoGebra, or I can use cos for that matter to find the maximum point. But let's do it by hand, just for fun. If I want to find the maximum point, I can put the derivative equals to 0, and I just differentiate this 28, and then I keep this constant 5 over 2, move 2 down, so I get 5 over 2 times 2, which means that 2 disappears, so I get 5 and then x to the power of 1, right? So this is the derivative, and I put this equals to 0, and I just move over and change sign and then divide by 5, and 28 divided by 5 would be 5.6. So x will be 5.6, and I just have to make sure this is a maximum point and not a minimum point. But look at this function here. It's a second degree function, it's a parabola, and the term of x squared is negative. So this means that this graph is angry. So this is a maximum point. So the area is maximized if x is 5.6. But we should also find what y is, and remember that what is y here. And the easiest thing here is to remember that the area is we know that y is equals to 28 minus 5 over 2 times x, and x is now 5.6. So y is equals to 28. Could have a calculator here. 2.8. This divided by this is 2.8 times 5. That will be 14. And then I will get y is equals to 14, like this. So x must be 5.6 and y must be 14. And what is the area then? We could just find the maximum point of this graph. and we would see that this was 5.6, and the area would be the y coordinate here on the graph. But I can of course put 5.6 into this formula, or just do it simple. I know that the area is x times y. That's how I find the area of a rectangle, this times this. So it's 5.6 times 14, which is something 56, and then 4 times this is 7.4, isn't it? No, sorry. 4 times this is 20, 22.4. So this will be 78.4, I guess. I may be wrong. 78.4, right? So that's the biggest area we can get, and then x has to be 5.6 and y has to be 14. If I did it by hand, you could do it on GeoGebra.